Scott, Rob Pahle from Arizona State University.
Okay, so I will talk today about CyberGIS and the complex systems framework. That's what I'm working on. And I'd like to pick up on a few of the comments that were made before, because I think we have maybe a small contribution for their solution, especially the incompatibility with models, which is very frustrating and complicated, I do agree. So what I'm going to do is I'm going to introduce the framework one more time and give a little bit of background there, then put that into the context of the CyberGIS and then give some examples of how that looks like. So, all right, so this is the chart of the framework, how everything is connected. And I have drawn this many, many times in many different versions. And we have programmed several iterations of this framework. And let me walk you through this relatively quickly. So at the core here in the middle, this is what the framework basically defines. It's yeah. So we have underneath here a workflow manager, and on top a syncing and collaboration server, which basically allows you to manage exactly what Rishi was trying to do between all the different clients, get data in and out. At the very bottom sits a set of simulations and or data. And this could be an arbitrary workflow. Now, the boxes here indicate that they could be on different servers. So they could be completely distributed on different locations. The gray area around this means that we rack them. And that's a concept that's commonly used, but the question is, how do you do that in an effective way so that you can connect things up easily, right? What we've done is basically we have created a REST architecture, which in itself allows you this coupling. Now, the problem is two problems. One is the data types. They are often incompatible. They don't go back and forth very easily. And yeah, well, there's several other problems. Yeah, one would be also, if you have very large data, you don't want to transport that data around all the time, right, in the system. Then on the other side, we have, and these are all services, basically. This runs on the web. On the other side, we have visualization services. They're essentially very similar constructed, except they interact with some kind of interface. Right? And what you can do is, by working on this workflow manager, you can compose elements and put them onto screens arbitrarily. And they can be as many screens as you want and as varied as you want. Also, once we're working on this, it turns out, from a computational point of view, as far as I'm concerned, there is actually no difference between an analytical service that does something to analyze and the actual data. The data and the services are the same. So for instance, and Rishi was mentioned this morning, there's services that provide data for census tracts. Right? So you say, oh, I want this extent of information and this detail, and it gives you the data back. An analytical service may say, hey, I take these parameters, and then I calculate something, and I give you a result back. Data and services are actually interchangeable. That was an aha effect for me, because the first version that I wrote, we had actually differentiated between data and services, data and analytical services, which you actually don't have to do. You may want to do that for people, because they view this differently cognitively, but from a computer point of view, it doesn't really matter. So originally also we had many more layers. So after converting everything to services, it was so much more manageable and simple to connect things up. So let's look underneath this. Technically, you can distribute things very easily nowadays. We have a lot of computer hardware, and this is where this ties into CyberGIS. So one of these services could sit on a cluster somewhere, Illinois, let's say, where you can calculate very big and fast computational models. There can be places where you store a lot of large data sets or a lot of small places. Then you just need very, very simple web servers. As you can see in the previous model, what we don't do, a lot of workflow systems, what they do is basically, or orchestration systems I should call them, they basically pull the data always into that orchestrator and push it out again. What we do is like, we never ever pull data into the orchestration engine because it just slows it down and it's actually not needed. And that gives a lot of flexibility of pushing data directly between analytical components, especially if they're on the same server. Right? If they're on the same hardware, if the analytics and the data is on the same hardware and you pipe things along, you never have to pull it out. So you can be very efficient as if you wouldn't do that as a service, in a sense. So they can be very lightweight. Then we have visualization providers, which don't really differ very much from these, except that they have some kind of interactions with screens, and they could run on all kinds of types of devices. So we've done a lot of different experiments and examples, and I'll show some later on, where you can run this on cell phones or tablets, desktops, up to big visualization environments where you have like 5, 6, 7 screens at once. So that's kind of how it integrates. So I'm pulling out this diagram here just to illustrate a little bit more how I see this integrating with CyberGIS. So CyberGIS is basically GIS on fast compute infrastructure, right? So I added here one component, which is a data service registry. This is what Jun Han is working on, in essence. That would collect these kinds of service sets. I would say, where can I actually find them? What can I do with them? This is actually, for me, the more complicated problem right now. If I have a lot of services available, which one do I use? And how do I actually combine them, right? So that is something where I see a quite pressing issue, right? So you discover, you figure out what's the best fit somehow. And then you create a workflow, and then you can execute that workflow. And basically, the workflow just says, well, there's a query, and it says, yeah, I have done this, but the data always flows in between the services directly. And there could be a variety of CyberGIS services. We try to come up with an example that runs in watershed or kind of water context. We'll see how well that works. All right, so here's an example of the backend. It's all web-based, by the way. It's all interactive. You can have several people at the same time working on this, and they all see the changes directly. So this is a very, very simple example. I have way more complex examples that I could show, but just for the time being. So basically, in the top here right now, you just type in what kind of model you want. And as I explained, the problem is, which model do I use? And let's say I have 10,000 models. Very likely the model that I want exists somewhere, but how do I actually find this and discover it? There are various different ways, but the problem is really that textual description sometimes is not enough. Maybe we need a variety of other mechanisms to find it. So yellow in this case are basically visualization elements. They go onto the screen somewhere. Green are elements that get just calculated. So I have a text input that gets converted into a floating point. Floating point that's typed into a division. I can do my division here, convert it back to a string, and put in text output. Very straightforward. I can do this also with maps or all kinds of other things. And then I have dashboards where I can actually show all these things. So an example of how this could look like. So here's an example where you have various types of elements on various screens. Various types of elements where you can put in parameters. Then you have a variety of models running, and you get a whole bunch of outputs. And this could be separate screens. They could be tablets. They could be a variety of things. They could be completely interactive, right? So one of the issues was the typing, right? So in this particular system, the idea is not to be semantically accurate. So if you look at SOAP services, these kinds of things, they try to explain what one of these components, one of these types actually is. So these are the inputs, these are the outputs, right? And I just connect an output to the input, and then here on the top are previous and next. This is actually the execution workflow. We separate out the execution workflow and the data workflow because you have more flexibility in working on things if they don't execute all the time. So if I would take the data workflow as the execution workflow, means I change the data, I run an execution. I don't actually want that. That's why they're separated out. You have to make 2 connections every time, minimum. Okay, so in this particular case, all we do is we say this is a string that describes the data type. Okay. And this has advantages and disadvantages. The advantage is I don't need to think about complex models, what my types are and how they work. The disadvantage is I actually don't know what they are and how they work. Right? So, however, so my proposal for this particular problem is to make a big registry server where everybody can register their data type. So, and what that allows you to do is you actually don't, from a service perspective, you actually don't need to know what the data type is. You just need to know its name, and if the name matches, I can just connect them up. I know they will fit. The assumption is that everybody that writes a service basically makes sure that the name is not already taken, and that the type doesn't already exist. Funnily enough, an example, we actually had 2 different services. So the Pahle REST version, we named integers int, and I wrote another version where I named integers integer, and they don't fit. Right? So the naming has its problems, but if you had a registry where you register all these things, you actually don't need to worry about that. And now the advantage is, if I don't know what this is, I can actually stuff anything I want in it. So I don't necessarily need a type that is a traditional. I can stuff an object into it, and we've tried that, and that works. So I can actually move, instead of just data, I can actually move code, for instance. I can say code and data is named X. So for instance, an example would be a Pahle W object, which actually can modify the weights or something like this. I can move the whole object from service to service very effectively. And I can make it as small as I want because I can do this binary. I don't have to take anything apart, right? I have an object, I stuff it in my container and I move it, that's it. So that's the advantage. Of course, both sides have to be able to interpret what that is. And you can see here that I have actually conversion containers in between, where it's like, okay, I take a value, I convert it to something else, and then they go on, right? That's the price you pay in essence, right? So, which is basically, that slows you down a bit. Okay. So let me see. So, yeah.
Question. You mentioned that we can search and name the model. Like at the bar, you mean like when you're gonna
These here?
at the top.
In the search box.
Yeah,
Here?
in the search box.
Yeah.
But,
You can just start typing and it finds you what models the system knows, and you can basically drag them down and instantiate them on the screen.
so for example, if you like to type something like water quality model,
Yeah.
and then
It will just bring you up a list right now. That's what I'm saying, there's a big deficiency.
so they will bring up the list of the model.
I could show it live, if you like, I could show it to you.
Just like how, but it doesn't mean like I can run the model on this. Like it just show like what the water quality model.
That's actually a very good question. That's actually a very good question. So, this is not intended for somebody that doesn't know what they're doing to necessarily learn what it is about. This requires, in this level, somebody that knows the domain somehow. So, in other words, we have three types of users. The first type of user can write or graph a service. That's a developer. I call them developer. They can actually code. Okay. The second type of user, I call an analyst. They know this backend here, and they know that if I take this value and I pipe it into another value, that it actually makes sense. We don't test if an integer is an integer that makes sense in another context. You, as the expert, needs to know that. Right? So in that sense, you need to be a domain expert already. You need to know that when I connect these things up, they do actually make sense. We don't do that for you, at least not in this version. And the third type of user is the user that goes onto the front end, right? Where you can type in parameters somewhere, and then you get your models to run, and it does some type of calculation, right? So, and I would call that a decision user or an end user or something.
They never see the screen that you just showed.
You can show them. My experience is you show them once, and then they nod very seriously and say, awesome. And then they never look at this again. I mean, you have to be able to show it. You basically can show them this screen, right? So I want to make it more fun. So one thing is where I see a big overlap with geodesign also, is that the analytical components, so in geodesign right now you basically sketch out, but you may want to run an analysis in the back end that shows you a particular detail. So what I'm working on is basically to collapse these workflows into a new service. Because you know what all the inputs are and you know what all the outputs are, you can actually collapse them in a new service and make that available. So you could make a relatively complex analysis and then run it as a service directly in a backend for one of the layers that could show you more information, right? Okay, and then these inputs here don't have to be they don't have to be text inputs. They also can be sensors. So the service, we have actually a mechanism in there which allows us to take new data in as soon as it's available, right? So that allows you suddenly also to run relatively big data problems because you can run the workflow every time data comes in, right? With the caveat that you may need a buffer somewhere in between because your whole pipeline could be too slow. Something like this. Okay. I wanted to see if I cut. Yeah, I think I got all the things that I wanted to talk about. All right, and then these are just a few examples of how things can look like. This is a model that is in energy. There are several big models. So here we have a model that looks at power lines in Arizona. The whole model looks at deployment of solar power, and then you have various GIS models which calculate the closeness to roads, et cetera, all these kinds of things. And then here you have a map where you can just draw your future power plant, and it'll run the whole analysis with a variety of models in the back end. That's one big workflow. Here we have a model that is more kind of a scenario. This is in Monterrey, Mexico, where there's flooding. You can see right here the flood. What you can do on another screen is basically you can start envisioning what are your actions that you intervene, and then you have a before and an after, and in the middle you see your actions. And you can see what the differences are over time. This is actually a 7-screen model. In fact, it looks more like this, where you can run across many screens, and you can see immediately the effect of what you're doing on the other screens, including we also kind of, when you develop scenarios, we kind of catch them in the end, and then you can compare them one by one with each other. So that's that.
Thank you, Rob.